Hi everyone, in this video we will use SPSS to perform a chi-square test of independence, which is also known as the chi-square test of association. So let's start with the basics. What is a chi-square test of independence? It's a statistical test that's used to determine whether there is a significant association between two categorical variables. What are categorical variables? Um, these are categorical data that fall into distinct groups or categories. So examples would include department of a hospital, which is, by the way, our example. So you have three departments: ER, inpatient, outpatient. You could have regions: north, south, east, west, brands of car, customer satisfaction level, satisfied, indifferent, dissatisfied. These are all examples of categorical variables. So this is the type of data that you will use for chi-square. Let's also understand what the phrase significant association means. It means that knowing information about one variable would give us useful information for predicting the other variable. So in our example, we'll use the example to illustrate this. Patients visiting ER, for example, might report lower satisfaction level than patients visiting the outpatient department. So knowing which department a patient goes to can help us predict the satisfaction level of that patient. Now let's also look at the null and alternative hypothesis. The null hypothesis is that there is no association between the two variables, meaning that they are independent. And the alternative hypothesis is that there is association between the two variables, so they're not independent. At significance level of 95%, if the p-value is less than 0.05, we will reject the null hypothesis and conclude that association exists. By the way, SPSS does not call p-value p-value, it calls it the asymptotic significance two-sided, but it means exactly that. It is the p-value. So the report that SPSS generates has a lot of components, but there are some that are more important or critical than the others. So let's look at what they are. First, of course, is the chi-square value, which is the size of the gap between the observed and the expected numbers. DF stands for degrees of freedom. The formula for that is rows -1 into columns -1. P-value, as I mentioned, it will be listed as asymptotic significance. Then we will also have Cramer's V. We'll also actually have a phi value there, but we're going to ignore that, and I'll explain why later. But we will have Cramer's V value reported, which deals with effect size, and there is a whole range of numbers that we will discuss, which will determine the strength of the effect. But typically 0 means that there's no association, and 1 means that there is perfect association. Then there's an assumption check that SPSS will report, and the assumption check will be that it should be that no more than 20% of the expected counts should be below 5. If that number is violated, then we end up having to reject or rather discard chi-square and use a Fisher's exact test instead. Now let's look at the scenario that we are going to use for our example. The scenario is this: that a hospital wants to know, is there an association between the department a patient visits and patient satisfaction? So for this data set, we have 120 patients, 3 departments: ER, inpatient, outpatient, and 3 satisfaction levels as reported by the patients: satisfied, neutral, and dissatisfied. So this is the setup and the scenario that we'll be using in SPSS. Now let's go directly to SPSS. So in SPSS, we'll start by uploading the file. To do that, go to File, Import Data, and you can have it in multiple formats. I have formatted the file in Excel. So once I click Excel, SPSS has recalled the folder where I have saved the file. So I'm going to double click on this, and the file, let's give it a moment to appear. Okay, so there's a dialog box here. We want to leave our variables name included on the top of your file. Yes, they are. So these were the variable names: patient ID, department, and satisfaction. A good idea to leave the second one unchecked, even though there were no hidden rows and columns. And depending on the type of data you're using, because I've created this data set myself, so I know that there are no leading spaces or trailing spaces, or even if there are, they won't matter. So we can leave those unchecked and click OK. So let's give SPSS a moment to come back up. Okay, now before we proceed to do the analysis, just a very quick hygiene check. In the variable view, we see that SPSS has actually correctly coded all the three columns. Patient ID is coded as scale, department is nominal, and satisfaction is also nominal. So now what we need to do is for chi-square analysis is go to analyze. Under analyze, go to descriptive stats, and from there scroll down to crosstabs. So in crosstabs, what we are going to do is department will be added to rows and satisfaction will be added to columns. But before we hit OK, there are a couple of other changes we want to make. So in statistics, we want to check chi-square, and we want to check phi and Cramer's v, even though we won't be actually utilizing phi for this. I'll explain why, but these are clubbed together, so we'll check this box. In cells, what we want to check is observed has been selected by default. What we want to check is expected. Continue, and then let's hit OK. And our report is ready. So let's examine this section by section. So case processing summary, this simply shows how many rows of data we had and if there were any missing cases. So there were none. Moving on to the department satisfaction cross tabulation. So I'd mentioned the formula for the expected count earlier. We can test one of the rows here to see how it's being calculated. The formula I mentioned was expected count, which is row total into column total divided by grand total, right? So let's take, say, ER and dissatisfied as an example. So the row total for ER is 40. The column total for ER dissatisfied is 34. The grand total is 120. So the expected value of 11.3 is derived by multiplying 40 times 34. So that's row total times column total divided by grand total. So that gives us a value of 11.3. The next thing to consider is the chi-square test table. So the Pearson chi-square value is 12.193. So this is the actual test statistic. It measures the overall gap between what you've observed and what you would expect if there was no association. The bigger this number, the more evidence that the two variables are related. So it's calculated by summing observed minus expected whole square divided by expected for every cell here in this table. That's how you arrive at this number. The degrees of freedom are 4. Again, the calculation for this is number of rows minus 1 into number of columns minus 1. So we have 3 departments, ER, inpatient, outpatient, and 3 satisfaction levels: dissatisfied, neutral, satisfied. So the degrees of freedom is 3 minus 1, that is 2, into 3 minus 1, again 2. So 2 times 2, that's 4. That's how the degree of freedom was calculated. Now let's look at the asymptotic significance, two-sided. The values are here. These are the p-values. So looking at the Pearson chi-square value of 0.016, what this 0.016 means is that there's a 1.6% probability of seeing an association this strong if department and satisfaction were truly independent. right? Now, since this is less than 0.05, we reject the null hypothesis and conclude that there is statistically significant association. SPSS has also reported a likelihood ratio, and sure, this is also useful in some context, but it gives a very similar result here. Most analysts, most researchers will actually rely more on Pearson chi-square. This is just another way of looking at it, at the same test. N of valid cases 120 just shows us how many data points we had, how many cases were included in the analysis. And let's also look at this footnote here. So this is the assumption check. So the chi-square test requires that no more than 20% of our cells have an expected count of below 5. So we have 0%. So if this number were any higher, for example, if this number was say above 20%, then we would have to discard this test and use something like a Fisher's exact. So, but in this case, we are well covered because our assumption requirement has been met. The last thing here is the symmetric measures, and we have phi and Cramer's v. So I mentioned earlier as well that we are not gonna consider the phi value. That's because phi is used only for 2x2 tables, and as you can see, our table is actually 3x3. So since our table is 3x3, the measure we are going to use for our analysis and reporting is Cramer's v, and the value for that is 0.225 and the significance is 0.016. Now Cramer's v values, these have a particular range. So for a 3x3 table, values between 0.21 to 0.35 are considered moderate. So our value is somewhere in the moderate range. So our association is moderate. So it's just kind of just above the medium threshold, which is 0.21. So there's a medium strength association. That's how we would put it. The approximate significance for the Cramer's v is also 0.016. So this is the p-value for the effect size measure. So it more or less matches what the p-value that we have for the Pearson chi-square as well. So to summarize, a chi-square test of independence revealed a statistically significant association between hospital department and patient satisfaction, with 4 degrees of chi-square with 4 degrees of freedom equals 12.193, p equals 0.016 with a medium size effect, and Cramer's v equals 0.225. Now, all in all, what does this mean for the hospital management? So looking at this this table here, we can see that ER had significantly more dissatisfied patients than expected, and outpatient had significantly more satisfied patients. So what this suggests is that ER may need attention when it comes to improving patient experience. And this, all in all, this is how you would run and interpret a chi-square test of independence in SPSS. Hope you found this video useful. Thank you for watching.